How you doing, everybody? My name is Lawrence Sumet. I am the product manager for lighting and rendering on Maya, and thank you for taking a piece of your afternoon to come and talk to us. With me, I have Nikola Milosevic, who's the principal product designer for lighting and rendering on Maya. And today, our goal is to take you through some of the things that we've been doing in rendering in Maya historically, give it a little context, and then talk and give you a bit of a picture into where we're going in the future. And at the same time, hopefully we'll have some time for Q&A and we can answer your questions. But really, our goal here is to give you some context, because often we go out and we talk to customers and there's a lot of confusion about where our products sit in the rendering space. So a little bit about myself very quickly. I worked for 10 years in production. I've worked in architectural visualization, commercials, music videos, kids episodic TV, film. I worked on the Fantastic Four. I've also been an instructor of visual effects for over 6 years in a college in Toronto, something that I enjoy a lot, and I do that part-time. And about 4 years ago, I joined Autodesk as a product designer on the rendering side, and recently moved into product management. And the cool thing about product management is that I get to go talk to all the customers that use Maya. And it's been a very interesting experience, because what I've discovered is that every pipeline is completely different. Everywhere I go, someone's doing a different technique. The artists are using different tools. They're using different renderers to end up and produce the pixels. But there is one consistent factor that I see everywhere, and that is at the end of that pipeline, at the end of the tool chain, there's an artist. And for us, that artist has been the critical factor in making sure we build tools that do the job. And the interesting bit is where Maya fits into that can often be sometimes very complex. So it might not be that we're building tools for the artist. It might be that we're building interfaces for developers to build tools for the artist. And that, again, is just all part of our job. Now, it's a bit rough out there for the artist. So especially in the lighting and rendering space, you're at the end of the tool chain, you're at the end of the pipe, and this organization tends to compound down to you. And people are doing more and more. Complexity is growing. The quality of images that you're producing is getting more and more engaging and more incredible, but at the same time, turnarounds, the time frames you have are actually getting smaller, and the budgets you have are getting smaller. And this can be very problematic and make life hard. You're also working with many different applications and trying to wrangle all that data. So these are the things that we're trying to pay attention to. At the same time, it's really exciting. You're at SIGGRAPH, you've probably seen seminars on physically based rendering and interactive path tracing and all the cool things that are happening in rendering. It's changing by the week. It's like there's a new renderer every month. So this is really exciting, and it's turmoil. And so amidst all this turmoil, we asked ourselves, how can we build tools that allow artists to focus on art and not technology? And the reality is, when it comes to Maya, we have some work to do. Our work is definitely cut out for us here. So for us, we see this problem as breaking down into 4 categories. And I apologize for the very boring PowerPoint-ish slide. This is my world now. So we look at rendering, we look at interactivity, allowing you to make sure that you're not waiting to see the changes you make. We look at workflow, how much labor you have to do to get to the result you need. And then we look at complexity handling. So I'm going to walk you through each of these steps and show you what we've been doing in the past couple of releases and also where we're going. So on the rendering side, we see a very cool image provided by our friends at NVIDIA, rendered in Iray. And let me start this one with a question. What renderer are you using today? Put your hands up for Arnold. Oh, we got a couple. How about RenderMan? Couple. Okay. What about Mental Ray? Okay. What about V-Ray? All right. Anybody using Redshift? Okay. Now, how about Maya Software or 3D Studio Max Scanline? Okay.
I teach it.
All right. We should talk after. So the point is, you can see like everybody's using a different renderer. At the end of the day, we're all doing different jobs. You have explosions that require complex particle systems and volumetrics. We have skin and hair and fur with subsurface scattering. We have hard surface rendering like cars, where you need very precise reflections. And we have globally illuminated interiors that needs the light to move in the right way. These are all different tasks. They require a different tool. And that is a good thing. It's often that, oh, Maya should have one renderer. There's no such thing. So at the end of the day, our focus was more on how can we make our products a better host for multiple renderers. And what you see here is a good example. So back in 2012, we did the Open Rendering project. And what this was is everywhere that mental ray, which was very deeply embedded into Maya, had a hook into Maya, we exposed that hook as a portal for any third party to plug into. And at the same time, added interfaces to allow third-party renderers to be more at home in Maya. So what you see here is a great example. When you create a light, often in Maya, previously you had to go and add V-ray attributes or add mental ray attributes or add the attributes for your renderer, and it just felt very tacked on. And so this is where we wanted to extend this, so we added a new type of interface that allows a third party to add an attribute that extends the base class of the Maya node, so that when you create a light and you have the Arnold plugin loaded, you get Arnold attributes right out of the box. And it's just one of the little things that third-party renderers are using to feel more at home in Maya. At the same time, what's really cool, and I think the mental ray folks here will like this, it allowed us to extract the mental ray from Maya plugin and work with NVIDIA to improve it. It allowed us to give them the plugin and let them do what they do best instead of being a blocker to improvement. And so here I'll show you a couple of examples. Back in 2014, this work allowed us to expose unified sampling in mental ray. And so this is a much simplified, instead of setting your samples on the lights and the shaders and the motion blur, this is one single quality control. And when you combine that with brute force final gather, so if you set all your values to 1 and then you turn off pre-cache for the final gather, you end up with this workflow where everything, all your quality is controlled by the one slider. And so you can trigger a render that gives you a predictive low quality render, and then when you're done, you crank it up and do your final render. So again, this is the kind of thing that came out of that relationship. And we were very happy with it. Also exposed the ability to use HDRs as lights. And this is a great workflow. I love this. I've been on film sets. And it's about using HDR photos of lights as area lights. And this gives you a very realistic result, gives you realistic reflections, and it allows you to work as if you're on a film set and you're using real light. This is something you find in many renderers. It's in Mental Ray now, Mental Ray for Maya, and it's a really good tool set for creating engaging images very quickly. We also have continued this process in 2015. So in Mental Ray for Maya for 2015, we exposed direct lighting for IBLs. So often when you're using image-based lighting and you have Final Gather turned on, you're just getting the indirect light. It's not a very good result. So we updated the emit light function, and that allows an IBL to cast direct light, shadows, and do it very quickly and efficiently without even the need for Final Gather. We also exposed the Mila layered shaders. So here I'm making kind of my own car paint. You can see I have a base diffuse color, and then I add a layer of very soft reflection. And then I add another layer of very glossy edge reflection. And this is kind of a roll your own car paint, but what's cool about this is I have control. I can adjust the glossy when the director says make it shinier. It's very easy to do without changing the underlying layers. So a great example of some of the improvements that came out of the Mental Ray Open Rendering work. So moving forward, interactivity. Our goal here is about allowing you to see the things that you need to see in real time, and not having to wait. And I'll give you some examples. So back in Maya 2014, we introduced the DX11 Uber shader. This worked in DirectX 11 on Windows, and you can see the results are awesome. So this is a shader that gives you real-time displacement, ambient occlusion, nice shadowing, image-based lighting, and it works on animated characters. Moving into 2015, Viewport 2 became the default viewport in Maya. And here you can see what you got out of that was improved performance and improved fidelity. Here's an example of projection in the old viewport. So it was very slow. You basically had to render to see what you're doing, and it really shouldn't be something you need to render to get. So here's Viewport 2 running in real time, and this is very indicative of what we were going after. It's just about seeing the details. I'm placing this bullet hole on the wall exactly where I want it to be, and that needs to be a real-time process. You shouldn't have to wait for that. Here you can see camera projection running in real time. And and we added particles, the fluid effects, the paint effects. This all now works in real time in Viewport 2 with much more fidelity than you got before, allowing you to see what you need to see in real time. So very exciting, and this is work that continues. as we move to improve past Maya 2015. So here you can see paint effects, and in here we now have a specular on the hair. It's lots of little things that give you more cues into what the final product's going to be so that you can make decisions faster. On the left, you see the old viewport choking on a heavy instance scene. We've moved instancing to the GPU, and that means that we're getting near real-time rates in viewport 2.0. So this is really exciting. We also improved some lighting things. So we have now shadows for ray trace lights, and we added a flat lighting mode to allow you to assess silhouette and just see your textures and give you a better diagnostic view. Also in Maya 2015, we introduced shader effects. So shader effects is a hardware authoring tool that comes with Maya in Maya 2015, and allows you to use a node graph to build a hardware shader that can compile down to CGFX, OpenGLES, GLSL, and HLSL. And it's a very cool tool. It allows you to build custom shaders. They work in the viewport, they work in real time, and they look awesome. And we have customers already using this to produce television and broadcast material and doing it in real time. And they're very happy about being able to work in real time. So moving into the future, this is an example of what we got cooking for Viewport 2. Often you'll hit 6 in Maya, you'll be waiting for textures to load, and it takes forever. Now, in a research department, we have background texture loading, so the textures stream in and allow you to continue working while you're waiting for the textures to come in. So it's a nice workflow improvement, allows you to keep moving very quickly. Shadows. Often when you're dealing with a big scene, you have a sunlight, the shadows can get pretty crusty. And this was a common complaint, so we're experimenting with new game engine style shadows and to give us better results. We've also been adding a feature to allow you to mark an object as a holdout, and that will pass through to the background, receive shadows, and this makes for a very nice VFX, animatics, and play blast integrated into a background plate. So really exciting stuff coming down the pipe. Now, the other cool part of my job is I get to hang out with some very smart people. And one of those smart people is Nikola Milosevic, our principal designer. And he's going to walk you through the workflow that's happening in Maya.
Cool. 1, 2? Yeah. So anyway, yeah, I joined the Autodesk, I guess, more than a year ago. And pretty much I work in the industry for a long time, I guess. And anyway, I have a chance to, I guess, work with amazing people like this guy. And pretty much what I'm concentrating in the last year and a half, it's workflow. And I'm going to show you some stuff we actually did for last year and something. Anyway, what's new in 2015, Maya 2015, it's UV tiling support. So UV tile support is really cool stuff. I mean, UV tile process is really cool stuff. And I don't know how many of you guys are actually using it, but highly recommend. One of the things you can do is actually you can have more than one artist working on the same geometry, on the same assets, and I guess they can work actually in different softwares at the same time, parallel, and actually that's really cool stuff. Anyway, the biggest bottleneck there before was actually Maya in 2014, prior to 2015. So basically what you have to do prior to 2015 is basically adding the one filing node per tile. And that's really prone to a lot of user mistakes, and it's really, really odd workflow. What you do right now is just have to 2 clicks workflow. It's just you have to add filing node, and you have to navigate it to a tile, and pick it up any of the tile, and then basically what you have to tell us exactly where did you build your tiles. So in this case, I built in Modbox. You can be ZBrush or Mario or anything. So and that's it. You basically can render, or if you want to render in VP2, you just have to generate the preview, and your tile is going to be shown in VP2. There you go. Whole character rotating there. Anyway, what's cool about this workflow is that you can have only one filing node, and that filing node can be connected to a bunch of shaders. In this case, we connect that to the 7 shaders. And so we have simplified workflow, and it's really, really easy graph. There's no complexity. We simplify complexity. And anyway, for those guys right now, I'm seeing a lot of here mental ray guys. We can render that to mental ray, and other parties coming to, and later I'm going to show you in the Admiral too. What's next thing? 2015 extension, it's color management. So color management is actually built on sync color component that is originating from Flame. And by saying that, I guess we can actually implement that to any kind of Autodesk products after this. So I'm going to show you color management implementation to build up one shot, classical VFX shot. So to do that, like I guess when you're building your shot, first you have to make a few decisions. First, I guess you got to enable color management in the My Preferences. Then you have to make a decision exactly what kind of rendering space you want to use. In this case, it's going to be scene linear space, Rec 79 sRGB. And obviously, you got to make a decision when you want to render this, metal array, and I guess when you want to comp it. In this case, we're going to comp that in Flame for this example. So let's do that. So we have a plate that is captured with Arri camera, and we're going to use the image plane to load that plate. And the only thing what you have to do is just pick it up proper color space. That's the only thing. No gammas, no anything. So in this case, we already have the color space for the specific camera, and it's Arri log C. So there you go. Your plate suddenly is in the linear space. The next thing is like I'm going to work on the lighting. In this case, I'm going to use the image-based lighting, and we actually use HDRI file that is actually created with the sphere on camera. We already linearized that HDRI image, and since Mental Ray already applying the raw color space to the IBL files, we are fine there. So if you can see that right now, those two plates, plate and HDRIs look like exactly the same. So next thing, what you do all the time is actually working on the textures for the characters. So in this case, if in Photoshop you apply the sRGB color space to this specific texture, you can actually load this texture really quickly, like I showed you before. In this case, this is tileable texture. So we navigated to the tile. So in color management, obviously, supporting tiles. And I have to just say exactly what's the tiling mode that I use. In this case, is I build this in Mudbox. So I'm loading the Mudbox, tileable texture, and then I pick it up to color space. I set up my default color space to be sRGB because I use that all the time. So I'm fine. Then there you go. You have Sven texture exactly shown in VP2, and it's in linear color space. So let's render that. In this case, we're rendering in Mental Ray. There you go. Bang. Looks beautiful. So what I'm going to do next thing? So I guess I got an email from VFX Soup telling me, like, Nikolai, you can't use this Rec 79 gamma or sRGB. We have a LUT file, so you got to use proper LUT file. No problem. So I just say, add new under the view transform, and I'm going to load 3D LUT in this case. So I navigate to the file, I set up my source transform, which is in log, save it, and there you go. You have a LUT file automatically showed in the render view and on the viewport too. You can see that, and we support all viewports. So later I'm going to work in lighting. So by saying this, I just want to actually sample the clouds on this HDRI image from viewport 2. So because we actually in the full floating point in viewport 2, and we're actually not clamping HDRI, I can do that really quickly right now. You can see that. I can see the clouds. I can sample value from the clouds, and color picker is fully color managed. So anyway, and that's my value there. I apply this value from the clouds. And if you want to use textures instead, this value, you can do that. Make sure you're actually adding color space, proper color space. I guess it should be raw because it's going to be linear. If you want to pick from the websites, that's fine too, because we apply inverse transform on the picker. And in this case, if I turn off color managed pots, you will see exactly our color in rendering space. Yeah, in rendering space. Anyway, if I turn back, you will see exactly what's our rendering intent. And that's it. So it's fully color managed. You don't need to add any kind of gammas or something. So I render that frame. And anyway, I'm in Flame. I just basically comp that file, simple comp, and apply proper LUT file. Anyway, that's a comparison. Left corner, you can see LUT. You can see the Flame image, and in the right corner, you can see the Maya one. It looks same. Then I got an email from, nasty email from production saying, Nicola, this is too dark. And I was like, why is dark? Why? Because we actually didn't bake transform in. So they don't have this view transform ability to see this like we are. So we have to bake transform for them to see that properly in their, what's the name, tracking software, let's say, or email in this case. So we just have to go to the apply output transform, pick it up transform what you want to do it. In this case, I use the same one, same LUT file, and I basically render it. You can render in hardware render too, and one thing we did in color management, we apply full apply. We actually added full support for EXR for XR. So you can actually run a full floating point or half point, and there you go. This render is looking really bright. Why? Because we actually double transform. You have a double LUT file there. So if you turn off view transform, you're going to see exactly how it looks like. And then I got an email from production that is actually saying, "Oh, you're genius. Thank you." Which is happening sometimes, by the way. Anyway, but they said, like, "Nikola, you got to render this in Arnold right now, and you have to comp that in Nuke." And I say, "No problem. I'm going to call guys in Spain who's actually working in Arnold." They say, "Guys, can help us?" And they actually did. They implement a color management solution in Arnold. And they actually even help us to switch those shaders. So right now, same shot, same everything, and it's rendering in Arnold. But then I have to actually see this image and comp actually in Nuke. So what you have to do in this case, I guess you got to use OCIO. So we fully support OCIO. In this case, I got to load this OCIO config file, and whatever is in that specific config file, we're going to expose that in our UI. And anyway, Arnold is still rendering behind. So I'm just say, use OCR configuration, and we're going to switch all these color spaces from everywhere where we applied into the what's the name, the OCIO, and whatever is actually in config file that you have is going to be propagated in our UI. In this case, rendering space, you will see there's actually a bunch of there, and the view transform same everywhere. So I guess I'm fine with this. I'm finished my lighting, and I want to render out. I want to render this character and send that to Nuke. So the cool stuff what we did extra for the render view in color management is you can actually save EXRs from render view. You couldn't do that before. You couldn't do floating point from render view before at all. So right now, actually, I did it. I basically save this file not in linear color space, like say raw image data, and I load this file in Nuke. So in the case you want to do that, like when you're testing something, you can do it right now. And there you go. Let's go Nuke. And you have like simple comp in Nuke, and we used exactly the same OCR config file and exactly the same settings, and let's see how it looks like. So left corner, this is Nuke, and in the right corner is Maya. So we have same user experience everywhere. That's exactly what you want. And next thing, but not last, in color management, what we did is just to help you guys, we applied the policy file for the color management. What is that? This basically is going to help you to actually have like color management settings established per shot basis, per sequence basis, per studio, per show. How's it working? We recording all these attributes from the color management, and you can load those attributes using environment variable on the Maya load or on the rendering time. So then basically you can change any kind of values there and having like different LUTs per shots in this case. Yeah, so that's pretty much color management so far, and it's actually in the extension, my 2015 extension. So the next thing what we're working on, it's about future directions. Like, so in this case, it's a look developer. So we talk a lot, we think about Lawrence is like me and everyone else, and we say like Hyperspace, it's having really odd workflow. It's really difficult to connect anything. It's really old. All these attribute editors, connection editors coming in, and it's like really, nobody knows exactly what you do. And if you select something, and if you go to attribute editor, it's like you have so many tabs, you don't know what you just selected. It's really, really old workflow. It's really hard to do something, especially for new users, so I have to say that. So we decide it's enough. Like we're gonna start doing like some kind of work on a Hypershade. So first thing what we did, we added actually node editor inside the Hypershade. And node editor is not perfect exactly. We have to do a lot of fixes there. One of the things, first thing we did, we actually simplify connections. So usually it looks like this. It looks like you have, when you add nodes, it's going to add so many connections there, and you don't know what you're doing. It's really complex, and you say, I give up. So what we did, we simplified those connections to the point that to the area that we think you always want to use it. In this case, filing node, we just show you out alpha and out color. But if you want to see everything, you just click another click there, and it's going to show you everything. Same thing for multiply node. We just simplified that to the input 1 and 2 and output. So right now, honestly, I built this like in 2 minutes. I speed up this, but it was just like, it was done in 2 minutes, and I start connecting this like out color, input color, and it's very simple workflow, and it's really not intimidating. We're trying to make stuff simple for you guys so you can actually do it easily. So next thing what we did is actually we added property editor for selected node in node editor. So it's not attribute editor. So when you select a node, we're going to show you exactly what you want to see. In this case, we're going to show you for the file node, what do we think you want to see it all the time. If you want to see everything, all the attributes is there. You just click a button, and it's going to show you everything. We don't want to confuse you with so many data. Like you want to be able to just connecting nodes and selecting nodes. You don't want to always do the drop down and all kind of stuff, opening stuff. So it's a pretty cool workflow. So we add a few more buttons there so you can actually remove property editor from there. In this case, if you click this button there, you can remove it. You can do copy tab, same thing like from the attribute editor too. So this is just for the node editor, showing you exactly what you're doing. Tabs, you can switch between tabs. They're going to retain positions like between when you're switching them or when you load the Maya. So that's very important. We're working still on that. There's one other team there working on a shaderable. We add a shaderable. In this case, right now I'm rendering in mental rate. There's 2 shaders. If you select 2 shaders, we're going to add 2 tabs on the right on the property and editor. So you can switch between tabs, and it's going to show you how shaderable is actually rendering. Yeah, we added custom geometry. I mean, not custom, like custom primitives there inside. But later we're working on if you want to add maybe custom geometry into the shaderable and render it with the custom geometry. It's non-blocking feature. You can still really scroll it and see exactly your output, whatever you actually change, whatever attribute it should be, not real time, but there. The next thing is soloing. So let's say you have a problem that you want to change the bump on this character value and the specular value. The director said that, you want to do that. So how do you do that? So you just go there and select a node and say, render this in VP2, everything upstream to this node. And this is what you're seeing right now. I'm rendering just this bump node, whatever it comes to that point. And I can easily change values and seeing them exactly as I'm actually changing the attributes. And the future thing we're trying to do, we're going to do it probably is we're going to actually even send that to the render view in this case. Anyway, I'm changing the specular value easily. I know what I'm doing. I'm seeing the glancing angles, and anyway, this is a cool example. I want to see exactly what the subsurface gathering doing. So this is the group of nodes that I'm going to solo up to the node that I select right now, and that's the soloing thing. Anyway, back to the guy.
Thank you, Nicola. Thanks, Nicola. So where to next? And this is the big question for us. We gave you a kind of picture of what we've been up to, what's going on in our labs. And the big question is, where do we move from there? And it's really around complexity. You're being asked to do more and more and more, and the software needs to address that. So our question became, how can we build tools that allow you to work the way a director thinks? So if the director says, okay, I want the left side of this frame to be a bit darker, that could be weeks of work for an artist. So how do we make that a simple operation? Now, you're all probably very familiar with this frame if you use Maya and you render in Maya. Maya render layers are effectively a state saver. They're built on direct connections. And the problem is when the input data changes, it doesn't really handle it in a deferred way. And it's just not built to handle a level of complexity that is being aspired to. So we see the future in conditional connections. And this is really where we want to go, is instead of saying this object has this material, it's this object that matches this condition, like Star hardcover gets this book material. And if we take these kinds of decisions and expand them into all the things you do as part of the rendering pipeline, you could end up with a graph that allows you to define how you do your look dev and how you set up your rendering, and it allows you to make those very sweeping decisions very simply. In this case, this is just a mock-up, but we see I want to take everything tagged foreground, isolate it from the rest of the stuff, and then within that set, anything with the material that has the name metal, I want to up the specular 10%. This is the way the director thinks. We want to give you tools that work that way. So that's one aspect of complexity. The other is actually computing that data. So, you're still limited by what you can load into your computer. And at the same time, like I said, the desire to do more is there. And so you shouldn't be limited by that. And so we've been looking at the cloud. Now, you're probably getting a bit sick about hearing about the cloud, all-seeing, all-knowing, all-dancing, awesome thing. But we're very interested in the cloud. And the reality is we're actually pros at cloud rendering. A360 Cloud Render has produced its 10 millionth render. And it's very focused on industrial design, architecture, and we've come to learn that the facilities on the cloud rendering for dealing with that market just don't scale to film and television. And yeah, everybody's nodding their head. It's just not there yet. So we're trying to understand what are the problems, and is there a way we can bring the power the cloud has to you as a user in a way that works? And so we did a little experiment. You're probably going to be seeing quite a bit about this in the future. I'm going to give you a little tease. Hyperspace Madness is an internal project. It's being done by developers, designers, and program managers and QA at Autodesk on their own time, using the tools we have and the resources we have to try and live in your shoes. And it's actually pretty tough. So we started with some concepts, and this got into animation. I'll give you a little tease. I'm not going to show you the whole thing. But I just want to give you an idea of what this is. So we had some nice animatics and storyboards done for us. And you see Spaceman Sven here fixing a satellite. And then bad things ensue. And our goal was to get 4 shots lit, rendered, and comped for SIGGRAPH. It seemed like a reasonable goal. But at the end of the day, we got animation, and like often happens, animation came in quite late. We had 2 weeks, 0 time and 0 resources to render Hyperspace Madness for SIGGRAPH. But here you see the final product. So go easy on us, I'm a bit rusty. But we managed to get the rendered out. And the way we did this was pretty cool. Our friends at Amazon actually helped us spin up a render farm on the cloud. And what made this work was we were doing Hyperspace Madness with a set of crew that existed in different time zones, in different locations. So we decided to use Box Sync to store our data. And then we mapped a common drive to that Box Sync folder. And this is similar to Dropbox or Copy or Google Drive. And what that meant is that the data was already up on the cloud. And so it was very simple for Amazon to hook that data up to those render farm nodes and spin up a render farm like that, and that is how we got that rendered. Now, this isn't a scenario that really maps to real world, but to us it speaks to a promise of bringing the kind of complexity and computation that we see in the cloud with virtualized computing to the end user, you. So just a bit of a recap. On the rendering side, we focused on making our products a better host for multiple renderers. On the interactivity, we focused on the things, the details you need to see in real time in Viewport 2.0. Nicola showed you some awesome labor-reducing workflow enhancements, trying to get you to focus on the art and not on how to hook stuff up and dealing with laborious things. And then the future for us is about managing workflow and complexity, allowing you to make artistic decisions on complex data sets, and also ensuring that you can compute these complex data sets and you're not barred by the limits of your machine. And that's our presentation. Thank you very much for listening. And I think we have a bit of time left. If anybody wants to ask any questions, feel free to hop up to the mic and we'll see what we can do. Please, please. Oh, you can yell. It's all good.
This thing's on. Oh, it is on. My question's regarding color management and the plan for linearizing your material swatches. I noticed on the node graph you showed you were still using gamma correct nodes, and if you plan to use linear space for adding that node in future releases.
Yeah, so gamma correct nodes is like I show you Untitled Chapter, so that was not used in any color management video that I showed. That was just like in the prior, because we didn't expose color management 2015. All videos from 2015 extension, we didn't use color management, so you don't need to do that at all. So everything is color managed so far as we're speaking, so you don't need to use any kind of gamma nodes at all. That's gone.
Check them out.
That's good to know.
Yeah.
This may be a naive question. I used to do lighting years ago. The first time I did lighting, I was using proprietary software at a studio you've heard of. And one of the things about the light shaders is that you had both the intensity and the exposure. And typically the visual effects soups would specify, oh, make the fill, a third darker or something, a third. And I got really used to that. And I also got to the point where I could judge the various lighting levels based on that exposure. But what I noticed is when I went to other studios, the shaders and the light shaders that I used didn't have that feature. And so my naive question is, are there shaders and renderers where you can now set up a light, not only have the intensity, which you might keep the same, but also have that exposure that you would probably be adjusting more? And I think that perceptually, we perceive that more naturally.
It's a great question. You'll find in many of the third-party renderers that work in our software, they have lights that are set up already that way. And I think it's a cool idea because it's a general move to perceptual uniformity, so that when you're adjusting a slider, it's adjusting in a space that is akin to what you're seeing and the way you're thinking. Yeah, so it's there. Jump on in. Thank you.
Saw you had the shade effects, which is I guess for the viewport shaders, and then you had the node view in the Hypershade, I guess, or the new shading methodology. Are those the same, or are they different, or can they work together? Or how do those work?
It's a great question. So shader effects is a different node graph, but it's a node graph that is the material. And so you can use the look dev editor you saw to connect textures up to it. But at the end of the day, you're absolutely right. There's still two editors, and our goal eventually is to unify them into one. Any other questions? I'm surprised there's no mental ray specific questions. That's great. All right, I guess we'll call it at that. Thank you very much for taking the time. Enjoy the conference.
Thank you.